In the previous videos, we have seen how we can train a multilayer perceptron with PyTorch and Lightning. Let's now talk about computing metrics, such as the accuracy, efficiently using TorchMetrics. So TorchMetrics, like PyTorch and like Lightning, is a free and open source library. You can actually install TorchMetrics using pip install TorchMetrics, just like you installed Lightning before. So what is TorchMetrics and how does it work? So here are a few screenshots of the code that we used to compute our accuracy previously. So the compute accuracy function receives a data loader, and then we are iterating over this data loader. So for each batch, we compute the labels using the model, and then we count the number of correct predictions. And after we counted the number of correct predictions, we compute the average to get the accuracy over the dataset that the data loader is looping over. So why do we compute the accuracy or other metrics incrementally? So one of the reasons is memory limitations. So usually we assume that we can't load the whole data into memory. Or even if we could load the whole data into memory, the model usually can't do the predictions on the whole dataset. Or in other words, it has to process the data bit by bit. So computing metrics incrementally helps us deal with big datasets. And also, if you think about the training loop that we use, it's also useful in this context where we only have a batch at a time. So TorchMetrics follows actually a similar concept as our compute accuracy function. And it computes the accuracy and other metrics incrementally. So we can now modify our compute accuracy function using TorchMetrics. So here these blocks are the parts that we are going to change. So first up here, I'm instantiating a new accuracy object. So here we are using accuracy for a multi-class problem with 10 classes. And then in each iteration, I'm computing the accuracy between the predicted class labels and the true class labels. And the accuracy class will then internally track the accuracy while we are looping over this whole dataset. And then to compute the accuracy for the whole dataset, we call .compute, which then gives us the accuracy. So the previous example covered how we use TorchMetrics to compute the classification accuracy. However, TorchMetrics implements many additional metrics for PyTorch. As of today, there are in fact now more than 90 metrics implemented in TorchMetrics. So now that we are familiar with how TorchMetrics works, let's actually add the TorchMetrics accuracy to our Lightning model in the next video.